Video, we are going to discuss these three limits. We are going to evaluate these three limits using L'Hopital's rule. So the first one, number 10, we have limit as x approaches to 0, 1 minus 2x, and then raised to 1 over x power. All right, so this one here is what you have to know. So this is a variable raised to another variable, right? So we have a variable raised to another variable. We have an x in the base and x in the variable. So raised to another variable. This is a sign of doing what? This is a sign of doing log differentiation. So log differentiation. So here is how I am going to do it. The function, I'm going to call that y equals to 1 minus 2x and then raised to 1 over x. So logarithmic differentiation, I ln both sides, so ln y. So once you ln the right hand side, so based on the power rule of natural log, we are able to bring the power down and then ln 1 minus 2x. Now, I am going to take the limit on both sides. So we have limit as x approaches to 0 of ln y equals to limit as x approaches to 0 of the right hand side, so which is ln 1 minus 2x divided by x. So let's see if we have a 0 over 0. So we have ln 1 minus 0 divided by 0. So ln 1 is equals to 0. Then we are able to apply L'Hopital's rule. So we do L'Hopital's rule. And then this is limit as x approaches to 0. The derivative of 1 ln something is 1 over that. And then using chain rule, we take the derivative of the inside. We have a negative 2. The derivative of x is equals to 1. So overall, that is equals to limit as x approaches to 0, negative 2 divided by 1 minus 2x. All right, so once you plug in 0, then you have a negative 2 divided by 1, then you have a negative 2. So this is the answer, right? So now here is how we read this. I bring this equals to this. So we do the writing again, then we have limit as x approaches to 0. We have ln y equals to negative 2. All right, and then how do we solve this? This is based on a formula. So the formula, let's put that in red. So let's say we have a equals to b. Here is the formula. A equals to b is the same thing as e to the a equals to e to the b. So let's say 2 is equals to 2. Then e to the second is equals to e to the second, right? So that is based on this formula. And then we do this. Then we have limit as x approaches to 0, e to the ln y is equals to e to the negative 2. And then what is e to the ln y? So e to the ln y, this is just equals to y. E to the ln 1 is just equals to 1, right? Or e to the ln 1 is e to the 0, which is just equals to 1, right? So e to the ln y is just equals to y. Then we have limit as x approaches to 0, y is equals to e to the negative 2. And then what is y? Y is the function, right? Then limit as x approaches to 0. So y is the given function, 1 minus 2x. And then what raised to 1 divided by x, that is equals to e to the negative 2. And then this is my answer. So that is number 10. And then number 11 is more complicated. Number 11, we have limit as x approaches to 0 from the right. I have 4x plus 1 and then raised to cotangent x. So since we have a variable as a base and then raised to another variable, this problem, we have to apply logarithmic differentiation. Right, logarithmic differentiation. Okay, let's go ahead and do logarithmic differentiation. So first, what do? We have y equals to 4x plus 1 and then raised to cotangent x, and then what? And then ln both sides. So we have ln y. So once you take ln on the right hand side, you bring the cotangent down, and then you have ln 4x plus 1. Right, 4x plus 1. And then what do? And then we take limit on both sides, right? So, and then we take limit as x approaches to 0 from the right, ln y equals to limit as x approaches to 0 from the right, cotangent x times ln 4x plus 1. And then is this an indeterminate form, cotangent x? You probably don't remember the graph of cotangent x as x approaches to 0, right? So let me remind you what the graph of cotangent looks like. You can look it up online really quick. So cotangent, okay, so this is the y-axis is a vertical asymptote, and then the next vertical asymptote is in pi. So this is from 0 to pi, and then between 0 and pi, we have this. So that means as x approaches to 0 from the right, we have a 0. Okay, so we have a 0. So as x approaches to 0 from the right-hand side, actually, it's not 0. So as x approaches to 0 from the right, the function approaches to positive infinity. So therefore, this one, the cotangent x is a positive infinity. Plug in a 0 to the ln, you have ln1 equals to 0. So infinity times 0 is an indeterminate form. However, this indeterminate form is not 0 over 0 or infinity over infinity. So at this point, L'Hopital's rule is not applied. In order to make the L'Hopital's rule apply, then we are looking for infinity over infinity, or 0 divided by 0. Okay, so let's go ahead and then make that happen. So x approaches to 0 from the right. What is another way to write cotangent? So cotangent x is the same thing as 1 divided by tangent, right? So we can just put the cotangent in the denominator and then change that to tangent x. The top is ln 4x plus 1. And then what is the graph of tangent? The graph of tangent looks like this. We have two vertical asymptotes, one at pi over 2 and then one at negative pi over 2. The graph of tangent looks like this. As x approaches to 0 from the right, at this point, we have 0, right? And then you plug in a 0 to the top, then you have ln1 divided by 0. Then that is 0 over 0, then L'Hopital's rule is applied. So since L'Hopital's rule is applied, we are going to go ahead and then apply L'Hopital's rule. Limit as x approaches to 0, the derivative of tangent is secant square x, and then the derivative of ln is 1 divided by everything inside the parenthesis times the derivative of the function inside the parenthesis using chain rule. So the derivative of 4x plus 1 is equals to 4. And then what do we have? We plug in a 0, right? So once we try to plug in a 0, we have a 4 divided by 0 plus 1, secant 0. Secant is 1 divided by cosine. Cosine 0 is 1, so 1 divided by 1 is equals to 1. Then overall, that is equals to 4. So what is equals to 4? Let's grab a highlighter. We have this equals to 4. Let's write this out. So overall, we have a limit as x approaches to 0 from the right. We have ln y is equals to 4. And then we take e raised to both sides. So we have limit as x approaches to 0, e to the ln y equals to e to the 4. And then e to the ln y is just equals to y. So we have limit as x approaches to 0, y is equals to e to the 4. What is y? Y is the given function. So limit as x approaches to 0 of the given function, 4x plus 1 raised to cotangent x is equals to e to the 4. So e to the 4 is my final answer. So that is the answer of number 11. Let's do the last one. The last one is also a logarithmic differentiation. So the last one is number 12. So number 12, we have limit as x approaches to 0 from the right, we have 1 plus sine of 3x, and then raised to 1 over x. So since this is a variable in the base, a variable in the exponent, then we have to do logarithmic differentiation. Y is equals to 1 plus sine 3x raised to 1 over x, and then we ln both sides. We bring the 1 over x down, ln 1 plus sine of 3x. All right, and then now we do the limit. So limit on both sides. This is ln y equals to limit as x approaches to 0 from the right. The other side we have what? The other side we have 1 divided by x times ln. Oh, actually I can put this as one fraction, right? Okay, let's rewrite this. Fraction bar x and then ln 1 plus sine of x, sine of 3x. So let's plug in the 0. So sine of 0 is 0, right? Then we have ln 1 divided by 0. Then that is 0 over 0. So L'Hopital's rule is applied. Then we apply L'Hopital's rule. X approaches to 0 from the right. The derivative of x is 1. The derivative of ln is always 1 over that thing. And then using chain rule to take the derivative of 1 plus 3x, that is equals to cosine of 3x. Using chain rule again, the derivative of 3x is 3. Alright, so overall, this is limit as x approaches to 0 from the right. We have a 3 cosine 3x divided by 1 plus sine of 3x. Let's try to plug in. So cosine of 0 is equals to 1. And then sine of 0 is 0. So overall, that is equals to 3. And then we borrow our highlighter. We have this quantity equals to 3. And then we bring it down. So we have limit as x approaches to 0 from the right. We have ln y equals to 3. And then we take e raised to both sides. 0 from the right, e to the ln y equals to e to the third. So that is limit as x approaches to 0 from the right, e to the ln y is just y. And then this is e to the third. Since the y is our given function, we write one more line to make everything super clear. Then this is 1 plus sine of 3x raised to 1 over x equals to e to the third. Then e to the third is our answer of the limit. So overall, the limit is equals to e to the third. So that will be all in this video. If you think my instruction is helpful to your learning, please click the like, subscribe, and share this video out for me so my video can help more and more students to learn calculus. All right, I appreciate your help really much. I see you all in the next lesson.